Yes. Yeah. All right. So our goal today here, our essential question is to understand this thing called completing the square. So far we can solve quadratics by factoring them and using the zero product property, or sometimes we can graph them and see where the graph intercepts the x-axis for our two solutions, or we can solve them by using square roots like we did yesterday. And today there's going to be another way that we can solve a quadratic, and it's called completing the square. But it happens when a certain special type of polynomial occurs. So what I want you to do to start this off, all right, I've got these four problems here. I have A, B, C, and D. Right? I'll do A with you, and then I want you and your partner to do B, C, and D. And what I want you to do is I want you to look for a certain pattern that is developing. See if you can see it, all right? So let me give you an example for the first one here. If we're going to do a diamond problem, first of all, what type of polynomial is this? What's it called? It's called a trinomial. Good. And what type of a trinomial is it? Is it linear, quadratic? What is it? How do you know it's quadratic, everybody? Because of a degree of 2. Good. What number goes in the top part of the diamond here? Very good. How about the bottom? 6. Okay, positive and positive, so the two numbers have to be positive. What two numbers multiply to 9 and add to 6? You guys got it. 3 and 3. Okay? Good. So what do I do with those two numbers now? No, I don't need to split the middle term this one because the coefficient is a 1, but that's a good thought. Yeah, the product of two binomials. Great vocabulary back there, Cody. So this is going to be x what? X plus 3 and an x plus 3. I wonder, is there another way I could write this? X plus 3 squared. Good. So x plus 3 quantity squared. Okay, good. So that's what I would like you to do for parts B, C, and D. And I'm hoping that you see a pattern, and we'll talk about that pattern in like 2 or 3 minutes. So please. Cool. All right, let's do part B together. Sasha, what'd you get, man? Can you walk me through it, please? Mm-hmm. 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 Quantity squared. Okay, x plus 2, quantity squared. Good. And we agree with that? Is Sasha right? Yeah, Molly, give me C for me. 25 on top. Yep. And 10 on bottom. Yep. And you multiply 5 and add 5. So what'd you come up with? X plus 5. Quantity squared. Now, how come we can write these as x plus 5 squared? How come there's a squared there? Why is that? Because there are two exact, what do we call those two little pieces? Two exact what? Binomials, right? There are two exact binomials, and they're being multiplied together, right? Okay. And then how about this one over here? What do we come up with? 100 and then 20, yeah? So what two numbers make it work? 10 and 10. So what we get, how did this factor down? X plus 10 quantity squared. Okay, good. Now, here's the challenge to you. Does anybody notice anything at all about how these factor down? Yeah, Cody, what do you notice? Yeah? Oh, if you take the square root of this, you get that. If you take the square root of this, you get that. If you take the square root of this, you get that. If you take the square root of this, you get that. Wow. Awesome. Anybody else notice anything about that? Well, that's pretty amazing right there. I like that. Okay, is there then a connection between, so you've made one connection. Is there a connection between the same number and the lower one? Same number and the lower one. Same number and the lower one. It's half a, Anthony, what are you going to say, buddy? Divide by 2. Okay, so there's something going on with dividing by 2 and then squaring something going on, right? Okay, well, you guys, these have a very special name, okay? Each one of these, this piece right here, this one over here, this one over here, meh, and this one over here. All 4 of these are what are called perfect, P-E-R-F-E, perfect square, can't even spell, trinomials. Okay? And we love these things. The reason that we love these things is because it takes a quadratic, x squared plus 6x plus 9, and it simplifies it to an x plus 3 squared. We love these things. It simplifies. When you factor it down, it makes it much easier to work with. All right? This is the first step in learning about how to factor using completing the square. The goal will always be to create these things, perfect square trinomials. Okay? there will always be a way to factor them down to a binomial squared. Okay? So that's the first part. Does that make sense so far? You guys caught some of the patterns that I wanted you to see. You guys good? Okay, good. So here's what we're going to do. We're going to try and solve by completing the square. Is it okay if I just put C.T.S. for complete the square? Does that make sense? C.T.S. complete the square. I wrote that in the top of the title. Completing the square just means C.T.S. Okay. So let's try this one, and we'll work this out together. Let's do x squared plus 12x equals negative 3. Equals negative 3. All right. X squared plus 12x equals negative 3. All right. And we're going to solve this by completing the square. So remember, our goal, when we solve by completing the square, our goal is to create what? What's our goal? I said it right back up here. Our goal is to create what? What do we call these things? Our goal is to create a perfect square trinomial. That's our goal. So we're going to do that right over here with a perfect square trinomial. We're going to create this. And here's how we're going to do it. I'm going to say x squared plus 12x plus, and I want you to put a box right here. Okay, I want you to leave a space for something. Has to equal negative 3 plus that same thing on the other side. Because after all, it's an equation. And when we're dealing with equations, we have to keep the equation sort of balanced on both sides, right? Remember that rule? Whatever you do on one side, you also have to do the other side in order to keep the equation balanced. Does that make sense? Okay, good. Now, here is the thing. We want to create a perfect square trinomial right here on the left-hand side. All right? And the key to doing it is looking at this middle term here. This middle term. And so what I'm going to do is I'm going to tell you what I call the magic number. I call this thing right here the magic number. And the reason I call it the magic number is because it's the one number in the world that will create for you a perfect square trinomial, one of these. All right? And you already noticed that 9 and then the square root is 3 and then half of the 6 is 3. So I'm going to give you what that number is, and I want to see if you guys can create it. The number is 36. All right? Why is 36 the magic number? Where did I get that number from? Just look at it. See if you can see where I got the number 36 from. So far, 1, 2, 3, 4, 5 people have their hands up. 6 people have their hands up. 7, 8, 9, 10. All right? Where did the number 36 come from? How did I get that number? Who thinks they want to try and explain it? Damien, what do you think, buddy? 12 times 3 is 36. Yeah, but where did it? That's one way. But where else? What else did you say? Yes. Did I square 12? 6 times 6 is 36. Okay, what do you think, Morgan? You guys are on the right track. I divided 12 by 2. Which is how much? 6. And then what did I do with that? I squared it. So here's what I did. I took the number 12. I divided it by 2. And then I took that answer, and what did I do to it? I squared it, huh? So I got 12 divided by 2. I got 6 squared, and then I got 36. So that is that magic number. Now, whatever I do to one side, I have to do to the other side. So what number goes over here? 36. You guys with me so far still? Okay, good. Now, here's the cool part. Here's the cool part. This piece right here, this whole entire thing, guess what this is now called? A perfect square trinomial. That's what it's called. It's called a perfect square trinomial. Sasha. And perfect square trinomials can always factor down to a binomial squared. Who thinks they can factor it down to a binomial squared? It's the exact same problems that we did up here. Who notices what you see? What do you guys see? What's it going to be, guys? Very good. X plus 6 squared. X plus 6, all quantity squared. Awesome. Because if we did this, right, if we did 36 up here and 12 down there, we'd have a 6 and a 6, and we would just get x plus 6 squared, huh? Do you guys see it? There's a lot to see here, so it's an important day. You don't see it? You don't see it, or you do see it? You see it? Yeah, okay. Now, what do we have on the right side? Someone help me out. What's negative 3 plus 36? 33, that's it, huh? That was pretty easy, huh? Okay, now, it says we're supposed to solve. What would be my next step in trying to solve this? Yeah, exactly. Now we just take the square root. So I get x plus 6 equals plus or minus the square root of 33. And what's the last thing I have to do? You got it. X equals negative 6 plus or minus the square root of... Alright, we got x squared plus 6x equals negative 7. X squared plus 6x equals negative 7. Okay. And it says the directions say we're going to solve by complete the square. So, remember, what's our goal? We're going to keep our goal in mind. What's our goal to solve by complete the square? We want to create a perfect square trinomial. Good. Awesome. So we're going to write down, we're going to do x squared plus 6x. Then I want you to leave a space for a box. Leave a space for a box. On the other side, I'm going to have a negative 7 plus leave the space for the box. You have to add the same thing to both sides to keep the equation balanced. Okay, so that's what we're going to do. We're going to add the same thing to both sides. Now, some of you already know the magic number. What is the magic number? 9. Now, how do we get a 9 here? I don't see it. Yeah, divide 6 by 2, and then we square it, and that is going to give us 9. Because 6 divided by 2 is 3. 3 squared is 9. Good. Now, what will this become automatically? Perfect square trinomial. Good. How do you factor a perfect square trinomial? It's going to be x plus 3 quantity all squared. Very good. What do I have on the other side? 2. 2, right? Negative 7 plus 9 is 2. Now what do I do? Take the square root. Very good. What do I leave me with? Plus or minus the square root of 2. So then what? Subtract 3. So x equals negative 3 plus or minus the square root of 2. Okay, here we go. X squared minus 8x equals 9. X squared minus 8x equals 9. Okay. I'm asking you to solve by complete the square. So we're going to keep our goal in mind. What's our goal? Yeah, but what's our goal? To create a what? A perfect square trinomial. PST, a perfect square trinomial. Good. So we're going to write down x squared minus 8x. Leave some room for our magic number. All right. What number is going to go here and here in this case? What number do you think is going to be? How do you get positive 16? Negative 8 divided by 2 squared. How much is negative 8 divided by 2? What's negative 4 squared? Positive 16. Very good. You guys did it right. Okay, what will this become now? That's your perfect square trinomial. That's right there. That's what that always will become. How do you factor a perfect square trinomial? X? Ooh, is it plus 4? It's minus 4, and it's quantity squared. Very good. It'll always be this number here. It'll always be that number there. Cool, huh? Did you guys notice that? Look at this back one here. What if I did this? This would be 3, right? All squared. Notice that it factors to that number there. Did you guys know that? Okay. And then look, notice that the 6 is that number there, right? It's always that number. Okay, so what do we have on the other side? How much is 9 and 16? 25. Good. Now what do I do? Square root it. That leaves me with x minus 4 equals plus or minus how much? What's the square root of 25? 5. Oh, that's a nice easy one, huh? Nice easy one. So then what do I do? Add 4. Now, does everyone realize there's two answers? It's either 4 plus 5 or 4 minus 5. So how much is 4 plus 5? 9. And what's the other answer? -1. Very, very good. Okay, now hold on a second. Hold on one second, okay? Somebody keep this in mind right here. X squared minus 8x equals 9, okay? Keep that in mind. What was it, x squared? Help me out. Minus 8x equals 9. Is that what we had so far? Yeah. Okay, good. So let's see. Will this work if I do this? What would you expect to see? Okay, a parabola, right? Yeah. And what else do you notice about this particular parabola? Where is it crossing the x-axis? -1 and 9. Wait, what were our answers over here? What? No way. -1 and 9. Check it out. Do you guys see the connection between those two things? Yeah, it's where the parabola is going to cross the x-axis, right? Very good. Yeah, kind of hard to see here, but it's not written in standard form. But our answers, right, where they cross, are the solutions to our equation when we solve by completing